Hi, thanks for joining me. Today I'm going to be continuing with the theme of infinite series and looking to evaluate this one here. Now, in my other two videos which I've done, in which I evaluated 1 plus 2 plus 3 plus 4 plus 5 plus so on, and I ended up with a finite number, I abused a lot of maths and did things which I wasn't supposed to mathematically. It wasn't very rigorous. I was being a little bit naughty and a little bit cheeky. But today we are going to be doing things rigorously, and I will be proving or evaluating this sum here, and I'm only going to be considering it for r between 0 and 1 and not including 1, because in that range there, this sum here converges nicely. Okay, I'm going to be showing it in two different, evaluating this sum in two different ways, so let's get stuck in with the first way. Firstly, if we have just an arbitrary geometric series, so let's say a plus at plus at squared plus at cubed plus dot dot dot, and this is for t, or absolute value of t less than 1 as normal, so this thing here converges. If I do t times t, then a times t becomes at, which I'll write there. At times t becomes at squared, which I'll write there. At squared times t becomes at cubed, and so on. And then if I look at the difference of these two things here, t minus little t times t is just t 1 minus t, like so. And on the right hand side I just get a, and therefore dividing both sides by 1 minus t gives me big T equals a over 1 minus little t. Okay, that's just a standard formula for a geometric series. I've just derived it quickly there. Okay, so if t equals this, then t equals a over 1 minus t. Okay, cool. Now I'm going to define Sn to be this thing here. It's going to be r to the n plus r to the n plus 1 plus r to the n plus 2 plus dot dot dot. But by what we've just shown, this is the same thing as r to the n over 1 minus r. Okay, cool. Now I'm going to rewrite s in a different way so we can evaluate s. I'm going to write s in terms of a bunch of sn's and add up the sn's, and we'll have a closed form for s. So s, I'm going to firstly write out what it is and then explain why it's that. So it's one line and then a second line. Let's put the plus dot 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 there. Plus r cubed plus. Okay, so what have I done here? I've rewritten s as this, and why does this work? Well, look here, I've got 1r, and that 1r's there. And here I've got 2r squared, well I've got 2r squared there. Here I've got 3r cubed, well I've got 3r cubed here. 4r to the 4, 4r to the 4 here, and you see the pattern, it continues. And a little technical note, this is indeed valid, going from this line to this line. You may be concerned about rearrangement, but because this is an absolutely convergent series, we're happy to rearrange things and it doesn't affect the sum. That's just a very small detail, but I said I'd keep things mathematically rigorous. So yeah, this is fine. And now notice the first line, if we look back to how we defined Sn, this is the case n equals 1. So this thing here is S1. But then this thing here is S2, the case n equals 2. This thing here is S3. And then you can see the pattern. The next line will be S4, the next line will be S5, and so on. So S is equal to S1 plus S2 plus S3 plus S4 plus so on. Okay, now we can evaluate what S is. Okay, so remember Sn is this thing here. Let me write that to the one side so I can clean things up in just a second. So we've just shown that S is the sum of all the Sn's. So S is equal to S1 plus S2 plus S3 plus S4 plus dot dot dot. Now using our formula here, that's nothing but, in the case n equals 1, r over 1 minus r. Then the case n equals 2, r squared over 1 minus r. Then r cubed over 1 minus r. And then r to the 4 over 1 minus r, and so on. But now taking out a factor of 1 over 1 minus r, I get r plus r squared plus r cubed plus r to the 4, and so on. But this thing here is precisely S1, which is nothing but r over 1 minus r. So this thing here is the 1 over 1 minus r from here, times this thing here, which was S1, which is r over 1 minus r, and then that equals r over 1 minus r all squared. Wonderful, we've managed to show what s is in closed form. Now again, obviously this only holds for r between 0 and 1. Or in fact, it might work for smaller values of r, but then in that case, the technical detail about rearrangement isn't so clear. It's not particularly clear that it's an absolutely convergent series. That's why I kept r non-negative. But yeah, so we've shown s equals this thing here. That was the first way, and now I'm going to do it a second way. I'm going to keep the formula for Sn there, but get rid of everything else. Okay, and the next way we're going to do it is by calculus. Okay, so instead of calling this thing here S, let's call it S of R. So we're thinking of it as a function of R. Now I'm going to divide both sides by R. So on the left hand side I get S of R over R, and on the right hand side I get R divided by R, that's 1. 2R squared divided by R, that's 2R. 3R cubed divided by R, that's 3R squared. 4R to the 4 divided by R is 4R cubed, and so on. Now, if you look at this long enough, perhaps you'll notice it, but this is actually an exact derivative of something very nice. Okay, ddr of r. If I differentiate r, I get 1. If I differentiate r squared, I get 2r. If I differentiate r cubed, I get 3r squared. If I differentiate r to the 4, I get 4r cubed, and so on. This is precisely S1. R plus r squared plus r cubed, and so on. So this is nothing but ddr of, back using our formula again, r over 1 minus r. Now we can work this out exactly using, say, the quotient rule. It's going to be 1 minus r times 1 minus 1 times r all over 1 minus r all squared, or however else you want to differentiate it. I use the quotient rule. And then this thing here, on the top we've got a minus and minus gives us plus r minus r. So on the top we've just got 1 over 1 minus r squared. Okay, but that's s of r over r. So that means that s of r is equal to r over 1 minus r squared. Now obviously, perhaps I should have stated this at the start. In the case r equals 0, you can't divide both sides by 0. But if r equals 0, this is just a sum of a bunch of zeros, so it's quite obvious what the sum is. And yeah, we've shown it a second way that we get s of r is equal to r over 1 minus r squared. Anyway, I hope you have enjoyed this video. It's shown you another way of thinking about infinite series, and also the fact that in my other 2 videos I was abusing them and used tricks that I couldn't, but in reality you can't do that. You actually have to be very careful and take into account things like this, and also rearrangement. But you can also get some very neat results as well, and express this thing here in closed form. Anyway, I'll see you on the next one. If you enjoyed this video, please do consider liking and subscribing. But anyway, that's all for now. Have a great day.